नमस्कार बच्चों, मेरा नाम धन्या और हम लोग ग्रेड 11 केमिस्ट्री का थर्ड लेसन सीख रहे हैं जिसका नाम है पीरियोडिक क्लासिफिकेशन ऑफ एलिमेंट्स। मेरे पिछले वीडियो में हमने आयनाइजेशन एनर्जी के बारे में सीखा, इलेक्ट्रॉन एफिनिटी के बारे में सीखा और आज हम लोग इलेक्ट्रॉन नेगेटिविटी के बारे में डिस्कस करेंगे। ओके, सो स्टूडेंट्स, इलेक्ट्रॉन नेगेटिविटी। ओके, नाउ सपोज आई हैव a covalent bond. You know, covalent bond is formed between two non-metals. Okay, covalent bond is formed between two non-metals, and it is formed by the sharing of the electrons. Okay, they share electrons, and electronegativity means, suppose if any atom is electronegative, that means that particular atom will attract the shared pair of electrons towards each other. Attracting, okay? It will attract the shared pair of electrons towards itself. Okay, so in this case, in hydrogen chloride, chlorine is more electronegative compared to hydrogen, more electronegative compared to hydrogen. So it will attract the shared pair towards itself. Okay, and in that process, hydrogen will get a slightly positive charge and chlorine will get a slight negative charge. Okay, and this cannot be used for individual atom. This is for covalently bonded atoms. Okay, so that means electronegativity is a relative property. Relative property. For example, in this bond, we said chlorine is more electronegative than hydrogen. That is why it is pulling the shared pair of electron towards itself. That's why it is a relative property. Okay. Now, that is why it has no unit. Unit is not there. No unit because it's a relative property. Okay. So electronegativity we define as tendency of an atom to attract. It is not accepting, okay, attracting, just attracting the shared pair of electron in a covalently bonded molecule or in a covalent bond. So it's in a covalent bond. So please remember the term attract, not accepting, okay? Attracting the shared pair of electron where not an individual atom but in a covalently bonded molecule, and it does not have any unit. Okay, now moving on further, comparing electron affinity EA with electronegativity. I'll write it as EN, okay, short form, right? So first one, electronegativity, we just learned property to attract the shared pair of electrons in a covalently bonded atom, in a covalent bond, right? What about the electron affinity? Electron affinity means what happens over here? Energy is released. When is the energy released? When electron is added to a neutral isolated gaseous atom. So we are talking about individual atoms in electron affinity, right? So we talk about neutral, individual, isolated atom. But in case of electronegativity, we are talking about covalent bond. That means the atoms bonded by chemical bonds. Covalent bond. Okay. And what is the unit for electron affinity? Electron volt per atom and or kilojoules per atom. We learned, right? But we learned in electronegativity, it's a relative quantity, so it doesn't have any unit, right? So these are some major differences, okay? And one more, what I just discussed is, here we talk about isolated, when an electron is added to an isolated gaseous atom. So we talk about isolated atom for electron affinity. It happens for for isolated atom, okay, for one atom, right? That is why kilojoules per atom, electron volt per atom. It happens for individual atom. But what about electronegativity? It is defined for what? For whom? Defined for atoms bonded by covalent bond. Atoms in covalent bond. Okay, so these are some major differences. So here it is attracting the shared pair of electron. It's not accepting, unlike electron affinity. Okay, so these are some major differences. Okay. Okay, students, the next topic that we are going to do for electronegativity is factors on which electronegativity depends. Okay, so electronegativity EN, I have just written as a short form, electronegativity EN. Okay, first factor is the size. Okay, so if I have an atom of a smaller size, and if I have an atom with a bigger size, okay, who will be attracting the electron pair? Okay, who will attract the electron pair more? Obviously, it is the smaller atom, because the nucleus is uh, very close to the electron and it can pull the electron towards each other. But in the bigger atom, atom B, the nucleus is, or the positive nucleus is very far away from the electron, so it will attract, but less strongly than atom A, which is very small. Okay, so we can say electronegativity is inversely proportional to size. Smaller the size, more is the electronegativity, right? Now, coming to the next factor, which is the nuclear charge. So for size, it is the same as electron affinity and ionization energy, right? Now, the next one is nuclear charge. Nuclear charge, the number of protons, or I represent it as Z. Okay, so suppose if I have an atom with few positive charges, and I have another atom with many positive charges. Now, who will attract the electron? A atom or B atom? Here, B atom will attract the electrons more, right? So more the nuclear charge, more is the electronegativity. So we can write electronegativity is directly proportional to Z, right? So same is the case for ionization energy and also electron affinity both, right? So more the number of charges, more the value of Z, more strongly the electrons are attracted. Okay. So same rule for ionization energy and electron affinity, for size and nuclear charge, right? That's what we learned. Now, so this is the direct proportion for charge. The next factor, student, is charge on the cation. Charge on the cation. Cation, you know, atoms with positive charge, ions with positive charge, right? Now, suppose if I have Fe is for ion, Fe2 plus, Fe3 plus. Okay, both have positive charges. Now, who will attract our electron more readily, Fe2 plus or Fe3 plus? Obviously, Fe3 plus, it has less number of electrons. So definitely Fe3 plus will attract. So Fe3 plus has a higher electron affinity than Fe2 plus. So whichever ion has more positive charges, the electronegativity will be more there. So I can write electronegativity is directly proportional to what? Write it here. So I can write electronegativity is directly proportional to charge on cation. More the positive charge on the cation, more is the electronegativity. Okay. Then another example, Mn2 plus or Mn4 plus. So obviously Mn2 plus will be having lesser electron negativity than Mn4 plus, right? Because Mn4 plus is deficient of electron, right? Now coming to the fourth factor, which is charge on the anion. So here, what do you think will be the case? Charge on anion, ion with a negative charge. For example, if I have N minus, if I have N minus, N2 minus, N3 minus, what would be the electronegativity order? Here, already there is 3 negative charges. It is excess of charge, negative charge. Attracting electrons will not be done so readily. They will repel the electrons, right? So they will repel most. Here there is negative charge, but 2 minus. They will repel, but less than, so they will also repel. But in N minus, there's only 1 negative charge. So they will repel, but repel less compared to the other 2. Compared to the other 2, all of them will repel, right? So here in this case, the electronegativity will be more for N minus, then N2 minus, and then N3 minus. So what can I write? Electronegativity, can I say inversely proportional, opposite of that of cation, right? To the inversely proportional to negative charge on cation. Sorry, anion. We are discussing about anion, right? Anion. So more negative charge, less is the electronegativity. Similarly, so if I'm writing this in a box, similarly, if I take an example of O minus and O2 minus, who will be more electronegative? O minus will be more electronegative than O2 minus, because electronegativity is inversely proportional to charge on the cation, charge on the anion. Right. So these are the 4 cases. And we still have one more, which is called as, I hope till here it is clear, right? Now coming to the fifth one is hybridization. Hybridization, I know it's a new term. Hybridization. Hybridization is a term that we will be learning in our next lesson. Okay, bonding. Okay, so for now, please remember there are three types of hybridization that you have to learn: SP, SP2, SP3. What is SP2, SP3 and all, we will be learning in the next lesson that we will be starting. Okay, now here these three, if we compare the three types of hybridization, percentage of S character. So I'm just, for now, I'm just telling what is the condition, but when you learn about the, in the next lesson, when you learn about the hybridization, you will understand this better, okay? So percentage of S character, here this is 50%, this is 33.33%, and 25%. I'm talking about the percentage of S in these type of hybridization. Okay. Now, electron affinity is in the order SP more than SP2, then SP3. This is the order. Okay. So, as the percentage of S increases, S character increases, electron negativity also increases. So here the S character is 50%, so it is most. Then next one is 33.33, then SP2. The third one is 25, so it is, third one is SP3. So the percentage as the S character increases, the electronegativity also increases. So this for now, just remember, keep in mind, okay, when we do the next lesson, this will be more clear, okay? Okay, students, the next topic that we are going to do for electronegativity is trends in the periodic table along the period and down the group. Now, along the period, in the period, we always study from left to right, right? Along the period means from left to right in a periodic table. Now, along the period, you already know Z increases. That means the nuclear charge increases from left to right. So when the nuclear charge increases, what happens? The positive charge increases. So it will attract the electron pair towards each other, right? So what happens to the electronegativity? That also increases. From where? From left to right. The same case we studied for ionization energy also. We also studied for electron affinity also. All of them increases from left to right, right? And the reason you know, because of the increase in nuclear charge. Okay. Now, down the group, this is the general trend that we are discussing down the group. Okay. Down the group, what happens to the size? Size is increasing. The nucleus becomes away, right? And what happens to the incoming electron, or the electron that is getting attracted feels less attraction from the nucleus, right? So there is less attraction. So electronegativity decreases. Same is the case for ionization energy and electron affinity too. We learned the same thing, right? Now, students, please remember, among all the elements in the periodic table, fluorine has the highest electronegativity, highest electronegativity of 4. Okay, this you must remember. Okay, now there are also few more things that you must remember. Okay, so I hope till here it is clear. Now, students, when we solve the past paper questions, you will understand that electronegativity of some elements you have to memorize and keep. Okay, Otherwise, it is difficult to solve some questions. Okay, so there are some elements whose electronegativity you must memorize. For example, these are the elements that you must memorize: carbon, nitrogen, oxygen, fluorine, okay, phosphorus, sulfur, chlorine, bromine, and iodine. Okay, and fluorine, I already said it is 4. Okay, for carbon, it is 2.5. For nitrogen, it is 3. Oxygen, it is 3.5. For phosphorus, it is 2.1. For sulfur, it is 2.5. For chlorine, it is 3. For bromine, it is 2.8. For iodine, it is 2.5. You have to remember this because when you solve the past paper questions, you will understand that how these values are important. Okay, they might ask you to arrange them. Okay, arrange some elements. So these are some common elements that are found. Okay, so the most electronegative is fluorine. Okay, which is greater than oxygen. Oxygen is greater than nitrogen, and nitrogen is 3. Nitrogen and chlorine, they have the same value. Then the next one, they are greater than bromine. Bromine is greater than iodine, which has the same value as sulfur, right? Value is sulfur, which is greater than carbon. Carbon is greater than phosphorus, which is same as hydrogen. Please remember, hydrogen also has the same value as phosphorus, 2.1. Okay, so these are some common elements that you must remember, the values. Okay, so this is very, very important. Put a star and please memorize these values. Okay. Okay, students, the next topic that we are going to learn about is scales for measuring the electronegativity. Okay, the first scale is Pauling scale. Okay, and it was made by the scientist Pauling. Okay, and we learned that electronegativity is a relative property, right? Now, he gave a formula for measuring the electronegativity, according to which Xi A minus Xi B equal to 0.208 under root EAB minus under root EAA times EBB. It's not a big formula, don't worry. Okay. Now here, Xi A and Xi B, they are the electronegativity of A and B. Okay, here B and A. I've written Xi B first, so that's why I'm writing electronegativity of B and A. Now, EAB is the bond energy. Bond energy, what it is, we will be learning later. Okay, okay. Bond energy of AB. Okay, the values will be given. Okay, so it's basically the energy released when this bond is broken. That's bond energy. Okay, so here, so EAA will be what? More about bond energy we will be learning later. Bond energy of AA, BB, EBB is bond energy of BB. Okay, and when you substitute the values, and you can, whichever is greater, you can put the value first, chi A minus chi B. Okay, so here the bond energy should be written in this formula. In this formula, the bond energy you should write in kilocalories per mole, kilocalories per mole. Okay, so if it is given in kilojoules per mole, if suppose in the question, okay, these energy values will be provided, so you don't have to worry about it. Okay, so bond energy of AB is 100 kilocalories per mole or 20 kilocalories per mole. Okay, kilocalories per mole. These values will be given. Okay, so you have to memorize the formula. Okay, because when we do the past paper questions, you will know that finding out they might ask you to find out the electronegativity. Okay, so in case if you have to find out, so it's better to know the formula. Now, in case if it is given in kilojoules per mole, you have to make it into kilocalories per mole. Okay, and I'll give the 1 kilocalories is equal to 4.18 joules. Conversion, I'll give the conversion. This is the conversion. Or in case, if it is given in kilojoules per mole, in case bond energy in kilojoules per mole. Okay, if it is given in kilojoules per mole, you can do one more thing. What you can do is xi A minus xi B. I'll write in another color. Formula is the same, but you have to change one small value equal to point. Here, what did we write over here in this formula? 0.208. Instead of 0.208, we will write 0.1017. The rest is the same, under root EAB minus under root EAA times EBB. Only that is the difference in case the bond energy is given in kilojoules per mole. So students, this was our polling scale. This was given by the scientist polling. Okay. And according to this, chi A minus chi B equal to, this is the formula that you can use, where chi A and chi B are electronegativities of A and B. Okay. And these are the bond energies. Okay, which will be given, or sometimes they might give you the chi values and they might ask you to find the bond energies. You can find out. Okay, and the bond energy in the question, it should be given in kilocalories per mole. If it is not given in kilocalories per mole, if it is given in kilojoules per mole, then instead of 0.208, you can use in the formula 0.107. So the problem is solved. Okay, so sometimes they might give you the chi values. They might give you two values of bond energy. They might ask you to find the third value. Okay, so these are the questions you can expect. So better to memorize the formula. So this is another formula that you must memorize. Okay, this is the formula. I hope this is clear. When to use formula 1 and when to use formula 2. Okay, so if the bond energy is given in kilocalories per mole, you can use formula 1. If the bond energy is given in kilojoules per mole, you can use formula 2. Okay. Now coming to the next scale, which is these are the most common scales that I used. Okay, so second formula or the second scale that is used is Mulliken scale. This formula is very simple. This particular scientist said the electronegativity is the average of ionization energy and electron affinity, average. So this is divided by 2. Okay. Here, you know that ionization energy and electron affinity, they give the values in the unit electron volt per atom for both of them, right? Or kilojoules per mole. These are the unit for what? Ionization energy and electron affinity. Okay, students, so these are the two scales, Pauling scales and Mulliken scale. Okay, and the two formulas also you must memorize. Okay, so this is the third formula for Mulliken scale. This is the easiest, right? Now, coming to some applications of electronegativity. So these are the basic things, and when we do the past paper questions, you will get an idea what kind of questions they ask you, and please memorize the values that I have given you. Okay, that is very important. When we do the past paper questions, you will understand how important it is. Okay, now coming to some applications of electronegativity. Okay. In nomenclature, it is very important. Naming the compounds. Nomenclature, it is very important. How it is important? Because, for example, if I say hydrogen chloride, we recognize this compound by the name hydrogen chloride, right? Now, why not chlorohydrogen? Why hydrogen is written first? The rule is that the element that has higher electronegativity is written with a suffix "ide". This is the suffix that's used. Suffix means written at the end of the word. So that is why hydrogen chloride. So I have used the suffix "ide", right, at the end. So whoever has higher electronegativity, that will get the suffix "ide". Okay. Second one, or we can say the second compound, if I say TCl3, okay, comparing phosphorus and chlorine, who has a higher electronegativity? Chlorine has a higher electronegativity. Okay, chlorine is 3. I gave the values, right? Chlorine is 3. Phosphorus is 2.1. So definitely, who will get the suffix "ide"? Chloride. So we write it as phosphorus trichloride. Phosphorus trichloride. So whichever element has higher electronegativity will get the suffix "ide". Okay. Similarly, bromine and chlorine, whether it's bromochloride or chlorobromide. We know the values now. This is 2.8, this is 3.5. So definitely it is bromochloride. Okay, so this is one of the application. Okay. The second application, students, is to find the percentage of ionic character in covalent bond. Now, even if it's a covalent bond, there will be some percentage of ionic character. Okay, it's not 100% covalent. Okay, some percentage, very little percentage of ionic character will be there. For example, hydrogen and chlorine. We know that chlorine is more electronegative. So it will attract the shared pair, and chlorine will get a slight negative charge and hydrogen will get a slight positive charge. So there is a development of a polarity, right? Difference in charges. So because of this polarity, they have some amount of ionic character. Okay, because of the positive and negative pole that has been formed. Now, how to know the ionic character? Okay, so there is a small formula for this. Percentage of ionic character is given by 16 delta X plus 3.5 delta X. Delta X should be always positive. That's why I've written in a box like this. Okay. Okay. Where delta X is what? Difference of electronegativities. You know the electronegativities of some elements. So if any compound comes from the elements that you know, you can find out the difference, right? So always delta X is positive. Always it is positive. Okay. So suppose if you have to find the percentage of ionic character in HF. H and F both are nonmetals. Yes. So it will form a covalent bond, but there will be some percentage of ionic character. So this is the formula. You know that hydrogen is 2.1, fluorine is 4. So what will be delta X? 4 minus 2.1, which is equal to what? 1.9. Now, if you know delta X, you can use this in the formula. Percentage is equal to 16 times 1.9 plus 3.5 times what? 1.9 the whole square. So this will come to 43%. So this particular compound HF has 43% of ionic character, but more of covalent character. So only 43% of the ionic character. And also, you must remember that more the electronegativity difference, more is the ionic character. More is the ionic character. So the percentage keeps increasing as the difference increases. Okay, so I hope it is clear till now. So just memorize this formula. Okay, and the values of electronegativities of some elements that I told you have to memorize it. The next one is the bond strength. Bond, how strong is the bond? Bond strength. Bond strength is directly proportional to electronegativity difference. Okay, so more the electronegativity difference, more is the strength. For example, if I have HF, HCl, HBr, you know the electronegativities of all these elements, HI. So this is 2, hydrogen is 2.1, fluorine is 4, hydrogen is 2.1, chlorine is 3, hydrogen is 2.1, this is 2.8, this is 2.1, iodine is 2.5. Now, we just said bond strength, so you have to arrange them in any order, increasing or decreasing order of their bond strength. And we just discussed bond strength is directly proportional to electronegativity difference. Let's find out the difference first. Difference of electronegativity. In this case, it is 1.9. We just did a while ago. This is 0.9. This is 0.7. And this is 0.4. So which is the compound having the highest bond strength? Highest is 1.9, which corresponds to HF, greater than HCl, greater than HBr, is greater than HI. If they have asked you in decreasing order, the other way around, right? Now, this is how you apply these values. Okay. Now, this is the increasing order of the bond strength. Hi has the weakest bond. Okay. Now, coming to related to this, we have acidic strength or acidic character. You already know acidity is measured in terms of how readily H plus ions are lost or released, right? Now, in this case, Hi has the weakest bond. So if it has the weakest bond, do you think Hi will lose electron readily? Yes. So if the bond strength is weak, if the bond strength is less, that means those compounds will release H plus ions readily. So in this case, Hi is more acidic because the bond strength we discussed is the least. So Hi is more acidic than the next one, HBr. So the order is the opposite. HBr is having high acidity than HCl. This is higher than HF. Okay. So because these two topics are related, so I just discussed at the same time. Hope this is clear until now. Okay, students, one more application is metallic or non-metallic character. Okay. Now, if the electronegativity value is very high, okay, then that highlights the more tendency to attract the electron pair. Okay, so that means nonmetals have attract electrons more readily. So that means if the electronegativity value is very high, that means the element tend to attract the electrons. So that means that will be a non-metal. But at the same time, if the electronegativity value is low, that means it will be metals, because metals, they have the tendency to lose electron. They readily lose electron. And what is the tendency of non-metal? They readily attract electrons. So more high value of electronegativity shows that it's a non-metal. And if the electronegativity value is low, that means, if the electronegativity value is very high, that means it's a non-metal. It attracts the electron pair towards itself. A low value of electronegativity shows that it's a metal, because metals' general tendency is to lose the electrons. Okay, students, in the next video, we will be learning, practicing some past paper questions of NEET and JEE. Okay, so please study all the formulas, okay, so that it's easy for you to practice the past paper questions. Okay, in today's video, we learned about electronegativity, we studied about the trends, and we discussed some applications. Okay, so that's all for today, students. Have a great day. Thank you.